Scientists have described a neutron star with some truly unique magnetic field properties. It's such a startling finding that it could change how we understand these enigmatic objects, and could even represent the first neutron star of an entirely new class. Although they have a few core characteristics in common, not all neutron stars are built alike. Some have binary companions, some are all alone. Some, called pulsars, flash like a lighthouse as they spin. Magnetars have really strong magnetic fields, yet some neutron stars have no magnetic field that we can detect. For all that diversity, a neutron star had never been detected before with a magnetic field from one angle and without one at others. That is, until Russian astrophysicists made a close study of the neutron star called GRO J2058+42. GRO J2058+42 is a pulsar neutron star about 30,000 light-years 9 kiloparsecs away. Its binary companion is a type of star that spins so fast, it is spitting out a disk of material around its equator, a decretion disk. That's not super common, but not rare either. The neutron star has a spin period of 196 seconds, relatively slow for a pulsar, but not outrageously. It's also what's known as an X-ray transient object, with variable X-ray emission. It's been studied pretty well since its discovery in 1995, and almost everything about it had looked pretty normal, aside from one quirk: the star's X-ray emission can only be seen during bright outbursts, when it slurps up some of the material from its companion's disk. The spectral properties of GRO J2058+42 were poorly understood, so when astrophysicists from the Moscow Institute for Physics and Technology, Space Research Institute of the Russian Academy of Sciences (IKI), and Pulkovo Observatory caught the beginning of an outburst from the star earlier this year, they hustled into action. This swiftness allowed them to take new observations of the star with the space-based, high-resolution NuSTAR X-ray Observatory. And those observations revealed something called cyclotron features in the star's X-ray emission. These are lines in the X-ray spectrum thought to be produced by the scattering of photons off electrons in a magnetic field. Put simply, when you see these cyclotron features, you're seeing evidence of a magnetic field. Cyclotron features have been detected on around 30 neutron stars. But there was something a bit wiggy about GRO J2058+42's cyclotron features. The scientists took measurements of the X-ray spectra of the neutron star from 10 different directions. The cyclotron features were only found in one of them. Unlike neutron stars whose magnetic fields are there all the time, and those that have no detectable magnetic field at all, GRO J2058+42's magnetic field, the scientists found, was only detectable for 10% of the neutron star's spin period. This magnetic field hotspot has strength of 10 trillion Gauss at the surface, which is also pretty normal for a neutron star. But the extreme non-uniformity of the magnetic field structure has the team baffled. Divots and dimples aren't unheard of, after all, that's how the sun gets sunspots, but previously, such directional discrepancies in the magnetic fields of neutron stars were only thought possible in short outbursts from magnetars. This new discovery shows that neutron star magnetic fields could be much more complicated than we knew. Indeed, GRO J2058+42 could even represent the first of a new class of neutron stars. The structure of magnetic fields of neutron stars is a fundamental issue of their formation and evolution. On the one hand, the dipole structure of the progenitor star should be preserved during the collapse, but on the other hand, even our own Sun has local magnetic field inhomogeneities that are manifested as sunspots, said astrophysicist Alexander Lutovanov of the Russian Academy of Sciences. Similar structures were theoretically predicted for neutron stars as well. It is great to witness them in real data for the first time. The theorists will now have new factual data for their modeling, and we will have a new tool for studying parameters of neutron stars. Please subscribe our YouTube channel Listen News here. If you like the video, please like, comment and share the video.